So in that previous bipartite graph, all we represented was the kids and the colors they liked. This is all that represented is allocation. This is because the connections were not weighted. They didn't have numbers on them, so there's no best way to assign. So with numbers along so no connections are better than the others when there's no numbers. As soon as we weight the connections, when there's a number there, we can allocate them in an optimal way according to a particular objective. So in year 12 general maths, we're either going to minimize or maximize the total numbers. You should also represent the same info in a matrix. So some people ask me, what is the last topic about? It looks like a matrix, but we don't do matrix maths. It's almost like noughts and crosses what we're doing, okay? You'll see that in the second lesson today. The rows in the matrix represent one group and the columns in the matrix represent the other. And the weightings of the connections, they're the numbers that fill the matrix. So here is more the kind of graph that you'll encounter. I've got a bipartite graph below that represents swimmers A, B, C, and D, and then the different strokes. So BA is backstroke, BR is breaststroke, BU is butterfly, FR is freestyle. And then those numbers represent how many seconds it takes them to swim 100 meters. So what's better, a lower number or a higher number? Lower, that's faster, okay? So to introduce this idea, we're going to do these 3 steps just in order. Construct a matrix for this information. So have that graph nearby so that you can see it. And we're going to try to fill in this matrix for that. Can you see that the rows in this matrix represent the swimmers A, B, C, and D, and the columns represent the different strokes? So what number am I looking at if I want to know what A's backstroke is? What number in that bipartite graph would that be referring to? 56. A takes 56 seconds to swim backstroke. Someone help me out with A breaststroke. 59. Butterfly. 52. A freestyle. Yep. So what I'll do is I'll fill that in quickly because you can see what we're doing here. B backstroke is 62. B breaststroke 67, B butterfly 59, B freestyle is 49, C backstroke 55, C breaststroke 64, 58. Fill them in as I go to 51. I'm just saying it out loud for the video. D backstroke 58, D breaststroke 60, D butterfly 54, 48. There are questions like this in the exam. Every year, there's like 2 questions that are assigned to what the hell does 56 mean, okay? Please don't lose marks for that. If your question was, who's the fastest at backstroke? How would I deal with that? I'd look at the backstroke column. What's the smallest number? 55, that would be C, is the fastest. A backstroke, breaststroke, smallest number. Huh? 59, which would be A. Butterfly, smallest number. 52 would be A again. And freestyle, 48 would be D. Still no maths here. We're just reading numbers out. Now this, I don't even want us to get the right answer here because the second lesson here is where I teach you how to get the right answer. So how could we do this by trial and error? I want the fastest team. So if the fastest person was doing each stroke, A would be doing breaststroke and butterfly. B would be doing nothing. He just sucks. C would be doing backstroke, and D would be doing freestyle. But at Year 12 General Maths, these assignment problems, Everyone must be given a job. And it kind of makes sense because if A did breaststroke, he'd be friggin' tired and then he'd probably be slow for butterfly. So can this work? This thing that we set here, everyone doing their fastest stroke, is that going to work if each person only does one stroke? Is B doing a stroke? No. Is A doing just one stroke? No, they're doing two. So this doesn't work if each person is only doing one stroke. So let's trial and error it. Can anyone give me an assignment that's going to give me the fastest possible team? Is there a way that we could do that? Could we just, what's A the fastest at? A is fastest at, see, backstroke is 56. So breaststroke is 59 and butterfly is 52. Why don't we keep A doing 52 and then let B do breaststroke? So what if we did B does breaststroke because that's the worst of A, left over, and freestyle. Is that the fastest team? Do we know for sure? Is there another way that we could do it? We're only doing it by eye right now. I'm not giving you a system right now to find the right answer. What do you reckon is a better team that we could flip?
Well, I was thinking that D could do freestyle.
D.
Second fastest.
Yeah.
And then.
Isn't that what D's already doing?
Oh, sorry, no. B can do freestyle.
B does freestyle.
And then D can do butterfly.
D do butterfly. And then A is going to do what instead? C's definitely doing backstroke.
Yeah, and X does breaststroke.
A does breaststroke instead.
Yeah.
Is that going to be shorter? What is that? BRA 59. FRB is 49. C backstroke is 55. D butterfly is 54. What do those add up to? 59 plus 49 plus 55 plus 54, 217 total. Is that better than what the previous one was? Let's write that quickly. A butterfly is 52. B breaststroke that's really slow. That's the problem there. C back is 55. D freestyle is 48. Let's work that out. Let's see what the total is. 52 plus 67 plus 55 plus 48. It's definitely faster. I don't actually know if that's the right answer though, because I haven't given you the definite way. Did you have another option? Okay. I want to leave it like that. I want it to feel a little uncomfortable because then the Hungarian algorithm is where we're leading to, okay? And I want that left in the lesson too. So your first exercises are, you're drawing a couple of spider webs in exercise 12B.1. Do them all. There's not very many questions. And then the next one will ask you to do something like this and find the best solution by eye. Please do that. There's only a few questions there. I'll give you half an hour. And then the last lesson is what we're doing for the next week, and we're actually done. We're almost there, okay?